Question 5 is yet another question on the periodic table. So we're given the definition for periodicity and then a table of first ionization energies across period 2. We've got 3 members of period 2 there, lithium, carbon and fluorine, and we have to explain the trend. So what is the trend? The first ionization energy increases across the period, and that's due to the atoms having increased numbers of protons in their nucleus. You must say that the shielding is the same, and so therefore the increased protons but the same shielding means that the outer electrons are attracted more strongly, and so it's going to be harder to remove them when you're trying to ionize them. We have an unusual question here. Solid carbon exists in 2 forms, diamond and graphite. We know that. Explain why it's unnecessary to refer to carbon as either diamond or graphite in the ionization energy, table 5.1. Well, if you think about the equation that would represent the ionization energy, you would have carbon gas going to carbon 1 plus gas plus an electron. That would be its first ionization energy. And so what you can say is ionization energies involve gaseous atoms, and so there's no difference between gaseous atoms, carbon atoms of diamond, gaseous carbon atoms in graphite. It's the same thing. And the very last part of the question, so we've got the same 3 elements, and we're now asked to talk about or fill in this table to do with melting points. So the reasons for the difference in melting points. So we're given some information, we've just got to populate the rest. So the first thing, we've got to state the structure for carbon diamond. So it's obviously got a giant structure. What type of force or bond needs to be overcome when you're trying to melt it? So we're told there's a metallic bond in lithium. What do you need to break to melt diamond? Well, you've got to break the covalent bonds between the atoms. And then when we're talking about fluorine, to melt fluorine, you overcome van der Waals forces between the molecules. Remember, we're not breaking the covalent bond between those 2 fluorine atoms. It's the van der Waals force between the molecules. It's really important to say that. And then what sort of particles exist in these structures on which the forces are acting? So the metallic bond is acting between a lithium 1 plus ion and delocalized electrons. What type of particle is this acting between? The covalent bond is between carbon atoms. And what type of particle are these van der Waals forces acting between? It's fluorine molecules.